Hello to everyone. In this video, let us discuss chemical properties of third A group elements, that means boron family. Okay, let us see here. First, reaction with air. So, in atmospheric air, the major components we know which one are there: oxygen and nitrogen. These are which one here? That major components present in atmospheric air. So now here let us see what are the products formed by the reaction of boron, aluminium, etc. with oxygen and nitrogen. In this first we have to learn one thing here. In crystalline state, that means crystalline form of boron and aluminium or not react with which one here, oxygen and nitrogen, but amorphous form of boron and aluminium at somewhat high temperature react with oxygen and nitrogen. And first here third A group elements react with oxygen and form M2O3, that means trioxide, and another one here Mn type of nitrides. So these are the components formed by the third A group elements by reacting with air. So now here boron react with oxygen and forms B2O3, boric oxide, and with nitrogen that give which one means boron nitride. Okay, similarly aluminium produces Al2O3. Aluminium produces Al2O3 and nitride also formed here, aluminium nitride. Okay, now these are the which one, oxides and nitrides of boron and aluminium. So in this B2O3 is having acidic nature. When it dissolves in water, that produces which one, boric acid, H3BO3. That indicates acidic nature of B2O3. And Al2O3, Ga2O3, these two are having amphoteric nature. These two are having amphoteric nature. And remaining oxides here, In2O3, indium oxide, and Tl2O3, these are having basic nature. So this is regarding which one, oxides and nitrides of that third A group elements reactivity with air. Okay, then after that next one is reaction with which one here, acids, and also with alkalis. Let us see what are the products formed here. In that first, boron does not react with acids and bases. Does not react with acids and bases. And here aluminium react with which one, acids. For example, if you consider with HCl, that produces which one, AlCl3 and liberate hydrogen gas. So aluminium reacts with which one, acids, to liberate which gas means hydrogen gas. But one important thing we have to remember here, what is that? With concentrated HNO3, aluminium undergoes a passive state. After initial reaction, what happens here? Aluminium enters into passive state. Passive state means state of non-reactivity is called passive state. Why? Because here initial reaction is that create which one oxide layer. Due to the formation of protective oxide layer on aluminium, further it does not react with which one, HNO3. So for this reason, concentrated HNO3 is stored in aluminium vessels. Vessel made up of with aluminium used to store which one, acid. Because aluminium enters passive state, So there is no further reaction is expected. So that is one important thing here. And similarly, aluminium react with which one here? Bases. So now consider 2Al plus 2NaOH plus water. Now what we can get here? That liberate hydrogen gas and produces NaAlOH taken 4. Sodium tetrahydroxoaluminate and liberate which one means a hydrogen gas. So like that, boron does not react with acids and bases, but aluminium react with acid like HCl and react with base like NaOH to liberate hydrogen gas. And we have to remember this thing here. Aluminium with concentrated HNO3 enters passive state. That means that is passive after some reaction with concentrated HNO3. So this is reaction of that third A group elements with alkalis and acids. Now another one, reaction with halogens. What are the products? Let us see here. Third A group elements react with which one here? Halogens, and they produces halides. What is the general formula of third A group halides? Means MX3. So boron will give which halides here? BF3, BCl3, BBr3, Bi3. But here one important thing, Bi3 is less stable. So Bi3 we may not consider that as a stable one. That does not exist at room temperature also, because that is somewhat unstable. So now like that, Bi3 does not exist. That is somewhat unstable. Okay, then in this some important things we have to learn. What are those means here? If you consider aluminium chloride that exists as a dimer, Al2Cl6, of course above 800 degrees centigrade that dissociates into monomer, but up to that high temperature that aluminium chloride exists as a dimer. And let us see the structure of that aluminium chloride. So what is that structure means? Here we can draw like this. Here one chlorine, here also one chlorine, chlorine, chlorine. In this, how many dative bonds are there? Means two dative bonds are present. That means chlorine atoms donate lone pair of electrons to aluminium. So in Al2Cl6 structure, two dative bonds are present. Remaining or which one means covalent bonds. This is one important point to let us remember in case of which one? Halides of third A group elements. And another important one here, all these if you consider halides of boron, they are electron deficient because only 6 valence electrons are there. So these are all electron deficient. So by accepting lone pair of electrons, they act as electrical they act as which one? Lewis acids. By accepting lone pair of electrons, they act as Lewis acids, because here if you consider BF3, 3 bonds are there means 6 valence electrons are there. So they are able to accept a lone pair of electron and act as Lewis acids. Now the question is here, what about Lewis acidic strength of that trihalides of boron? So what are the trihalides of boron? BF3, BCl3, BBr3. No need to consider Bi3 because it is unstable. Now here the expected acidic order is, expected order of acidic strength is which one? BF3 greater than BCl3 greater than BBr3. Why we expect like this means, here if you consider the electronegativity of these three halogens, fluorine F is highly electronegative. So this can gain electrons from boron. That means that can pull back electrons from boron. So among all these three trihalides, the central atom in BF3, that is here this boron, that experience much electron deficiency, because among these three halogens, due to high electronegativity of fluorine, that pull back the bond pair of electrons towards itself, making boron electron deficient, in case of which one, BF3. So that means here among these three halides, boron of BF3 suffers much for electron deficiency. That means here, as per our expectation, boron trifluoride should accept lone pair of electrons readily. So expected acidic order is like this, but experimental order is controversial to this, opposite to that. Experimental order is, what is that order? BF3 less than BCl3 less than BBr3. So why this happened like this means, due to the back bonding. What is back bonding? Let us see here. For example, if you consider the boron, its configuration 1s2, 2s2, 2p1. That means in p subshell, two vacant orbitals are there, py and pz orbitals. In boron, 2p set of orbitals having vacant orbitals. 2p set of orbitals are vacant. Now if you consider the counter halogens, fluorine configuration, atomic number 9, so its configuration helium 2s2 2p5. That means fluorine is having lone pair of electrons in 2p set of orbitals. But if you come to chlorine and bromine, in case of chlorine, lone pairs are present in 3p subshell. In case of bromine, lone pairs are present in 4p subshell. So now here, in all these cases, boron is the central atom. But in case of fluorine, lone pairs are present in 2p set of subshells. But in case of chlorine, 3p subshells. In case of bromine, 4p subshells. But boron is having vacant orbitals, in which case means 2p subshell. So now here, in between 2p and 2p subshells, back bonding is easy. But in case of remaining halogens, 3p, 4p subshells are there. So now comparatively with 3p, 4p subshells, in case of BF3, there is a more, that means more convenient to form which one here, more chances for the formation of back bonding. Because in case of fluorine, lone pair of electrons present in 2p set, and here boron having vacant orbitals in 2p set only. That means here back bonding is easily possible in case of BF3. So now this fluorine donate lone pair of electrons to which one? Boron of BF3. That means among these three halides, due to the more ease of formation of back bonding in case of BF3, this central boron not having much electron deficiency, because due to back bonding, this boron gained that electron pair. Now this BF3 is not having much electron deficiency. So for this reason, that experimental order reveals that BF3 acidic strength less than BCl3 less than which one? BBr3. So this is regarding which one? Chemical properties of which one? Third A group elements and boron family. Okay, in our next class, let us go for compounds of boron, that is boric acid and borax, etc. Okay.